All right, question number 14. A wall in a conference room is 45 inches wide by 40 inches high. Will a whiteboard with a 50-inch diagonal fit in it? So we have this is our wall. Okay, and again it says it was 45 by 40. What they want to know is it possible for them to put a whiteboard, which would also be a rectangle, that has a diagonal of 50 inches. Now, the only way it's going to fit is if the diagonal of this wall is bigger than 50 inches. Okay, so we want to know, is this diagonal for the wall greater than 50 or less than 50? Okay, so I'm going to call this my x. Okay, I want that x to be greater than 50, or I guess I should probably write it that way. That's the way we're used to kind of seeing that. Let me erase my old one. Okay, so again, we need the length of x, that diagonal for the wall, to be greater than 50 so that this whiteboard with a 50-inch diagonal will fit. Well, how do we find x? Well, we can use the Pythagorean Theorem. We have a rectangular wall, so we know it comes to a right angle. We have two of the legs, and we're trying to find the hypotenuse so that we know if this will fit. So we do a squared plus b squared equals c squared. Okay, leg squared plus leg squared equals hypotenuse squared. We square the 40. 40 times 40 is 1,600. 45 squared, 45 times 45 is 2,025. We add those together. That gives us 3,625 equals x squared. Take the square root to get rid of the x squared. So the diagonal for our wall is about 60.2. So is that bigger than 50? Yes, it is. 60.2 is greater than 50. So yes, it is possible for that whiteboard to fit, and this would be our answer right here. Okay, it's possible. Now all we know is that the diagonal is the right size, but if one of the dimensions is wrong, it wouldn't work. So we say possibly. Diagonal doesn't restrict it. And see, this is our work we did here. We did 40 squared plus 45 squared, and then we took the square root down here to get 60.2, which was greater than 50. Identify the values of the variables. Give your answers in simplest radical form. So the first thing I notice is that I have a right triangle. The second thing I notice is there's a 30-degree angle here, which means this would have to be 60. So I'm dealing with a 30, 60, 90 triangle. Well, hopefully in your notes you wrote down how to find the parts of a 30, 60, 90 triangle. If not, the rule that I use is you always find the short leg first. Notice we have a short leg, we have a long leg, and we have the hypotenuse. Okay, now the short leg, when we're going to try to find it, we want to find it first. And it depends on what part you have. If you have the hypotenuse, it's the hypotenuse divided by 2. Okay. If you happen to have the long leg, we do have the hypotenuse in this case, but if you do have the long leg, it's the long leg divided by the square root of 3. We have the hypotenuse, so we're going to use this right here. We know the hypotenuse is the square root of 3. So our short leg is hypotenuse divided by 2. Our short leg is our x. It's equal to the square root of 3 divided by 2. They want it in radical form, and that is radical form right there, so we're just going to leave it. Next, we need to find y. Y is our long leg. The equation we can use for the long leg, it's always the short leg times the square root of 3. So to find it, our y, our long leg, it's the short leg, which we just found out was root 3 over 2, times the square root of 3. We go ahead and multiply those. Root 3 times root 3 gives you the square root of 9 over 2, and the square root of 9 is 3. So we end up with x being the square root of 3 over 2, and y just being 3 over 2. Here's number 16. Identify the value of x. So we're trying to find x here. Give your answer in simplest radical form. Again, we have a right triangle here. Okay, not just any right triangle, because see, this is a 45-degree angle, which means this is 45 also. We have a 45, 45, 90 triangle. We had special things that we knew about 45, 45, 90. One was that the legs were congruent. But that doesn't do us any good in this case because we're not looking for the other leg. We have the hypotenuse and we're trying to find one of the legs. Okay, the legs are congruent in a 45, 45, 90, but again, we move on. What else do we know? We know that the leg is equal to the hypotenuse, and this is just for a 45, 45, 90 triangle. It's equal to the hypotenuse divided by the square root of 2. Okay, and our final one is if we needed to find the hypotenuse, which we don't, we know at this time, you would go the leg times the square root of 2. See, these are kind of opposites of each other. But we're trying to find a leg, so this is our little formula we're going to use. So the leg, our x, equals the hypotenuse, which was 10, divided by the square root of 2. Well, it would be nice to be done right now, but they said write it in simplest radical form. In simplest radical form, you cannot have a square root in the bottom of the fraction. To fix that problem, what we do is we multiply by that radical. So we had square root 2, we multiply by what was there. And then our rules say that whatever you do to the bottom of a fraction, you also have to do to the top. So that's what we do. On top, that gives me 10 times the square root of 2. On the bottom, the square root of 2 times the square root of 2 is the square root of 2 times 2, which is 4. And the square root of 4 is 2. Okay, we're almost done. We got the radical out of the bottom. It's okay for it to be in the top. But now all we have is that, see, 2 divides into 10 5 times. So we end up with just 5 times the square root of 2. So you start by using your formulas for a 45, 45, 90 triangle, and then we simplify our answer. Identify the perimeter and area of an equilateral triangle with height 14 root 3. Okay, well, what does equilateral mean? First of all, it means all the sides are exactly the same length. Okay, they gave us the height, which would be straight up from the center here in an equilateral triangle. Our height is 14 times the square root of 3. We want the perimeter and the area. Well, for perimeter, we're going to have to find out what the length of each side is and add them together. For area, we do the base, which would be this whole bottom, times our height, and divide by 2. So what we need to do before we can solve this problem is find the length of these sides. We do that because we know that equilateral triangles have sides all the same length and also have all angles exactly the same. Not just the same, but all the angles in an equilateral triangle are 60 degrees. So we have 60, 60, and up here we've split this one in half. So this would be a 30-degree angle, and this would be 30 degrees. So if we look at our triangle that we have remaining, notice that it is a 30, 60, 90 triangle. Okay, we know that this side is 14 root 3. So we go to our notes and we notice, well, there's 3 different sides. There's a short leg, a long leg, and a hypotenuse. Here's the hypotenuse. Here's the short leg across from the 30, and we know the long leg. Our rule is always find the short leg first. We have the long leg, we want the short leg. So in your notes, you should have that the short leg is equal to the long leg divided by the square root of 3. Okay, in this case that would be 14 root 3, that was our long leg. If we divide by root 3, we just end up with 14. Okay, so our short leg has a length of 14, which means right here on my drawing, this portion is 14. What we wanted was the entire length of a side. Well, it's split in half here. We could go the extra mile and then go, well, the hypotenuse is the short leg times 2. But you could also look and say, well, if this is 14, it's halfway across, and this is 14, the whole side would be 2 14s or 28. And this is an equilateral triangle, so that makes the other two sides 28 also. So that was what we had to do first. And now I'm going to go back and answer the question. I'm going to redraw my picture here with my lengths. I know this side's 28, this side is 28, and my whole base is 28. I also know that I have a height of 14 root 3. Okay? We need to find the perimeter and the area. The perimeter is the distance around the figure, so it would be the sides added together, the outsides added together. So 28 times 3, or 28 plus 28 plus 28, which is 84 inches. There's our perimeter. For a triangle, again, the area is the base times the height divided by 2. Our base was 28. Our height was 14 root 3. And then we divide by 2. Keep going. 28 times 14 gives me 392 root 3 over 2. And then we go ahead and divide the 2 into that 392 to simplify, and we get 196 root 3 square inches. So it looks like our correct answer is perimeter 84 inches, area 196 root 3 with this option right here. Okay, so we're asked to find the orthocenter. Now the orthocenter, I'm going to, as we're talking here, graph these 3 points. The orthocenter is the point where the altitudes of each side intersect. Now the altitude, remember, is the perpendicular bisector of each side of the triangle. So what we need to do in order to find the actual orthocenter is we need to find what the equation for the perpendicular bisector of each side would be, and then find out where they intersect. So let's start with NM. It's actually going to be the simplest one to use. And again, we want to find the perpendicular bisector. So the first thing you have to do is find the midpoint. Okay, the middle of that line. Again, we're going from N to M. Okay, so we want the midpoint of 3, -7 and 3, 0. For midpoint, you add the x's and divide by 2, so 3 and 3. And add the y's and divide by 2, so -7 and 0. 3 plus 3 is 6 over 2. -7 plus 0 is -7 over 2. And if I simplify, 6 divided by 2 is 3. -7 divided by 2 is -3.5. Okay, so we know here, right there. Okay, the second thing we need is the slope of our line. Okay, now it needs to be perpendicular to this one, which is straight up and down. So what would the slope of the one perpendicular to it? It should be going, whoops, I missed my center a little bit, down just a little bit. There we go. The slope should be 0, perfectly flat for that line. So here is the altitude for the side NM. Okay, we need to find the altitude of one of our other two sides. It can be either one. I'm going to go with LN. So that would be the line going from L, which is at -1, -2, to M, which is at 3, -7. The first thing we need to know is the midpoint of our line. Okay, well, the midpoint is, again, we add the x's, so -1 plus 3, and divide by 2. Add the y's, so -2 plus -7. I guess I'm doing line LM instead, sorry about that. negative 2 plus negative 7 divided by 2. Negative 1 plus 3 is 2. Negative 2 plus negative 7 is negative 9. When I finish that off, 2 divided by 2 is 1. Negative 9 divided by 2 is negative 4.5. Okay, so that would put the middle of LM at 1, negative 1, 2, 3, 4.5. Okay, next we need to find out what the slope of our line is going to be. So we start by finding the slope of the line we have. Our other one was easy. It went straight up and down, so we could just go, oh, there it is. But not so easy with this one. We want to find the slope between negative 1, negative 2, and 3, negative 7. The formula for slope is y minus y, so negative 2 minus negative 7, over x minus x, so negative 1 minus 3. Minus a negative here makes this a plus, and I get negative 2 plus 7 is 5. Negative 1 minus 3 is negative 4. So I have a slope of negative 5/4. Now that's the slope of my line LM. I want the slope of a line perpendicular to that. So remember, perpendicular lines are opposite reciprocals. So our perpendicular slope is opposite, so instead of negative, it's going to be positive, and we flip the fraction. Positive 4/5 would be the slope. So here's my point. Up 1, 2, 3, 4, over 1, 2, 3, 4, 5. See if I can draw that line at all. Okay, so again, little rough when you're drawing with an electronic writer. There's the altitude for that side. Now my orthocenter is wherever those two intersect. They intersect right here at the point 3, negative 3.5. So my orthocenter would be the point 3, negative 3.5. They may have it written as 3, negative 7/2. They may have left it in fraction form. Right, identify the value of x. Well, we have a right triangle here. We have the three sides, so we can always use the Pythagorean Theorem, which is, again, going to come up over and over again. So hopefully we have this one memorized, or at least in our notes in bold print. Pythagorean Theorem says a squared plus b squared equals c squared, where a and b are the legs, c is the hypotenuse. So leg squared, one of our legs is 7, plus leg squared, our other leg is x squared, equals hypotenuse squared, our hypotenuse is x plus 1 squared. We square the 7, get 49. We square the x, it's just x squared. And this part over here is going to require some review from algebra. When you square something, it means taking it times itself. So when I square this, I'm taking x plus 1 times x plus 1, which required us to FOIL, which means we take the first times the first. So x times x is x squared. Outside times outside, x times 1 is just 1x. Inside times inside, that's our I, x, and last times last, 1 times 1 is 1. I'm going to simplify a little bit here. 49 plus x squared equals x squared plus 2x plus 1. I want to get the x squareds on the same side, so I have a positive x squared. If I subtract x squared, it will move it from this side. I have to do the same on the opposite side. And notice my x squared cancels, which is actually a very nice thing for us. And we get 49 equals 2x plus 1. I want to solve for x, so I need to get x by itself. I have a positive 1, so if I subtract 1, we'll move that. It gives me 48 equals 2x. And finally divide by 2. And I get x is 48 divided by 2, or 24. They wanted the value of x. I found the value of x, and I am done.